Hello class, welcome to Geometry Lesson 6-2, which is all about kites and trapezoids. By the end of this lesson, you should be able to use triangle congruence to understand kites and trapezoids. So first let's talk about kites, and we want to investigate the diagonals of a kite. So remember, diagonals are when you go from one side of a figure to the other, and see how A and C aren't right next to each other on the shape? I would either have to go through D to get to C, or I would have to go through B to get to C. That means that it is a diagonal. Now, with a kite, every kite has two pairs of adjacent sides. So we can see that it highlights that those two sides are congruent to each other. So AD is congruent to CD, and AB is also congruent to BC. So adjacent means next to. Remember, congruent means the same measure. And then some other important information about the diagonals of a kite. If we look, BD ends up intersecting AC at a 90-degree angle. That's a perpendicular, but it's also a bisector. It cuts this diagonal in half. So if AX is 5, CX is also 5. Okay, so you have a 90-degree angle inside there where the diagonals intersect, and you also have a perpendicular bisector. So the first question, what is the measure of angle AXB? Good luck. Hopefully you remembered me saying that the diagonals intersect at a 90-degree angle. So the measure of angle AXB would be 90. Now, the second question, if AX equals 3.8, what is AC? Hopefully you realize that AX is 3.8, that means CX is 3.8. So if we're trying to do from A to C, we're going to do 3.8 times 2, which is 7.6 units. All right, a third question, if BD equals 10, does BX equal 5? Okay, so I want you to think about that, and I want you to explain it. And what I mean by that is I truly want you to think about it. I'm not expecting you to type an explanation into the answer on Edpuzzle, but I want you to not just answer yes or no. I want you to know why you answered yes or why you answered no. So go ahead and think about it. If BD equals 10, does BX equal 5? Hopefully your answer was no. Even though BD, even though this purple line bisects or cuts AC in half, AC does not cut BD in half. So that means that BX is not equal to 5. All right, and then here is the theorem talking about the diagonals that are perpendicular, if you want to take a screenshot of that. And then let's talk through example 2. So we want to now use the diagonals of a kite. So we have the quadrilateral PQRS, and it's a kite with diagonals QS and PR. We want to know what the measure of angle 1 is. So if I look at angle 1, that's this angle right here. Well, we know that those angles inside are 90 degrees. So the diagonals of a kite are perpendicular, so the measure of angle 1 equals 90. Then my next question, what is the measure of angle 2? Okay, so if I know that this is 90, and I know that this is 35, I can do 180, because you can make it into a small triangle, minus 90 minus 35. And if I subtract all of those, I am left with 55 degrees. So the measure of angle 2 equals 55. Then our very last question is, what is the measure of angle 3? Well, if we look at this slightly larger triangle, remember how we said adjacent sides on a kite are congruent, or we have two pairs of them? Well, if I highlight those, you can see I outlined an isosceles triangle. And the reason I know it's isosceles is I have two congruent sides, And if we have an isosceles triangle, that means that our base angles, so angle 3 as well as the 35-degree angle, are also congruent. So I can say that the measure of angle 3 is 35. All right, question 2a. It's your turn to use the diagonals of a kite. We have a quadrilateral WXYZ, which is a kite, and we want to know what the measure of angle 1 is. So if I want to know the measure of angle 1, what would that be? Good luck. All right, hopefully you ended up with 58 as your answer for the measure of angle 1. And the way you got that was you split it up into a triangle. You remember that we had a perpendicular angle or 90-degree angle right there. We had a 32. So 180 degrees in a triangle minus 90 minus 32 leaves us with 58 degrees for the measure of angle 1. Now, I want you to take a moment and find what is the measure of angle 2. Good luck. Hopefully you said it is also 32 degrees. If you have questions about that, please be sure to reach out for some help, and I'd be happy to help you. All right, for example 3, we are going to explore the parts of an isosceles trapezoid. So for an isosceles trapezoid, remember, first of all, isosceles means that you have two congruent sides. So we have that here. They're marked with the red dashes. And then a trapezoid is like a triangle that has had its top cut off. So like if we look, I could turn that into a triangle if I had added that top there. But there are some properties about trapezoids that you should know. First, trapezoids are quadrilaterals. So building off what we learned yesterday with quadrilaterals, there are 360 degrees in them. Okay, you're going to use that information a lot to solve these problems. Another important thing you should know, remember with isosceles, the base angles are congruent. So that means that these two angles are congruent. But in a trapezoid, we also have another set of congruent angles. So if I ask, what is this angle right here, angle W, the way we can solve that is I can do 360 minus the other angles, right? So if angle Y is 70, that means angle V is also 70. And then I don't know what X or W are, so I'm going to use a variable. I'm just going to use M. And then they have to be the same thing, so I'm going to use M for both of them. So I can say that 70 plus 70 plus M equals 360. Or if I simplify, 140 plus 2M equals 360. Subtract 140 from both sides. I have 2M equals, let's see, that'd be 220. And M equals 110 degrees. One other thing with trapezoids, that's kind of a fun little trick, is whenever you have two lines between, or two angles between parallel lines, so here are my parallel lines, remember these are consecutive interior angles. So that means that those two, Y and X, those are supplementary. They add up to 180. Y and V, those are also supplementary because they're between the parallel lines. So that can be an even faster way to solve the problem, because I could have said 180 minus 70 and gotten 110 and been completely done with the problem. So if you can remember that trick, that's a good one. If not, you can always add them up and set them equal to 360. You get the same answer. Okay, why don't you go ahead and explore the parts on this isosceles trapezoid and figure out what the measures of angle P, Q, and S are. Good luck. Hopefully you got 135 degrees for Q, and then you got 45 degrees for P and 45 degrees for S. Go ahead and solve this other problem on your own. Good luck. Hopefully for this one you said, okay, I have a straight line here. If this is 47, this other side over here inside my trapezoid has to be 180 minus 47, which is 133 degrees. And then angle R is going to be congruent to angle U, which is the same as angle TUR. So the answer is 133 degrees. Here are two more theorems that basically summarize what we've been talking about already. So theorem 6.4 talks about how each of the base angles in each pair of base angles are congruent in an isosceles trapezoid. And the theorem 6.5 talks about how the diagonals of an isosceles trapezoid are congruent. I did not mention this yet. So the diagonals in a trapezoid are always in an isosceles trapezoid. That's very important. It's not any trapezoid. It's specifically isosceles trapezoid. Those are congruent to each other. I'm terrible at tracing lines today. Sorry. All right, and example 4. We want to solve problems involving the isosceles trapezoid. So let's say we have a picture that looks like this. This looks like a high voltage transmission tower. Let's do a problem with that. So if we know that all of the horizontal, so remember horizontal is going that way, are parallel to the ground. And we know that we have the top trapezoid is isosceles and the middle trapezoid is isosceles. So if we look at letter A, if the measure of angle 1 equals 138, and I want to know the measure of angle 2, how would I find that? Well, if this is 138, that means this is 138. So I can either say 138 plus 138 plus, I could say x plus x equals 360, or I can say 180 minus 138, because remember, the angles are supplementary, and I could say that angle 2 is 42 degrees. So you can either add them all up and set them equal to 360, or remember that trick. Then, let's say letter B, one cross support in the center of a tower measures 4c plus 3, and the other measures 6c minus 5. What is the length of each cross support? Remember, as I just said on the last slide with the theorems, our diagonals are congruent, and when things are congruent, we can set them equal to each other. So I can say 4c plus 3 equals 6c minus 5. Subtract 4c from both sides. I'm left with 3 equals 2c minus 5. Add 5 to both sides. I'm left with 8 equals 2c. Divide both sides by 2. And I get c equals 4. So then I'm not done though, because it says what is the length of each cross support. So I'm going to plug that 4 in. So if I say 4 times 4 plus 3, that's 16 plus 3, or 19. And if I want to check to see if I'm right, if I plug 4 into the other side, I should get the same number. If I do, I'm good to go. If I don't, that means my answer is wrong. So 6 times 4 is 24 minus 5. 24 minus 5 is 19. So since I got the same answer on both sides, it's safe to say that the answer is 19, and c equals 4. So why don't you go ahead and solve this problem on your own? Good luck. Hopefully for this problem you ended up with a equals 14. There's the work for you in case you need help. Theorem 6.6, this is the last new thing for this section, okay? Theorem 6.6 is all about the Trapezoid Midsegment Theorem. Remember, midsegment means that it's halfway. So this segment right there in the trapezoid cuts both of its sides in half. And if I know that this is 3 and this is, let's say, 5, if I wanted to solve for that middle segment, I would say xy equals 1/2 times AD, I said was 5. BC is 3. So I'd say XY equals 1/2 times 8, or XY equals 4. And that's how I'd solve that problem. So let's solve one that's really similar to that, but it's a word problem. So we have Paxton makes trapezoidal handbags for her friends. She stitches decorative trim along the top, the middle, and the bottom on both sides of the handbags. So how much trim does she need for 3 handbags? The way that we are going to solve this problem is we're going to look. We know that the top of this trapezoid is 6, the bottom is 9, so we need to solve to figure out what that middle stripe is. So I'd say, I'm going to call that middle stripe just X because I don't know what it is, equals 1/2 times 6 plus 9, or X equals 1/2 times 15. X equals 7.5. Then, since I know that this is 7.5, I want to figure out how much trim she needs for the handbag. So I have 6 plus 7.5 plus 9, which gives me 22.5. So 22.5 tells me the distance along one side of the handbag. So if I do 22.5, I need to multiply that times 2 in order to find both sides of the handbag. But then I need to do that amount and multiply by 3 in order to find the total stitching on 3 of the handbags. When I multiply those all together, I end up with 135 inches. All right, the last question for you. Go ahead and solve for KL. Good luck. Hopefully for your answer, you ended up with X equals 30 meters. If not, please be sure to reach out for some help. And here's the last slide with the concept summary, telling you a little bit about kites and trapezoids. So if you have any questions at all, please do not hesitate to ask, and I'd be more than happy to help you. Have a great day.